because it involves not the product rule, but what? Quotient rule. Quotient rule. So that's the framework. We know we can take the derivative of x, and if we have the chain rule at our disposal, we can also take the derivative of the cube root of x squared plus 4. That's a composition of two functions, each of whose derivatives we know how to find. So this is the quotient then of two functions whose derivatives we know how to find. And the quotient rule goes like this. F prime of x equals, take whatever's in the denominator, put it in the denominator, and square it. So what's in the denominator is x squared plus 4 to the 1/3. What do we get when we square x squared plus 4 to the 1/3? I suppose there's plenty of time to figure that out. You get that? While we're thinking about it, take that expression, x squared plus 4 quantity to the 1/3, and write it down right up here. X squared plus 4 to the 1/3. I didn't take the derivative of that, so it must be that we need to take the derivative of the numerator. So multiply by the derivative of x. No trouble there. And then it's a minus. Quotient rule is a minus, so it's why it's important to have the order of those two quantities in the numerator correct. So the first quantity, the one that I've written, is the denominator times the derivative of the numerator. And then we subtract the numerator times the derivative of the denominator. That's the framework. That's the quotient rule. So we take the necessary derivatives. F prime of x equals, okay, the derivative of x is 1. I could write the 1 or just kind of notice that it vanishes since we're multiplying by 1. Should I write the 1? It won't hurt to write the 1. X squared plus 4 to the 1/3 times 1 minus x times, okay, chain rule time. I want to take the derivative of x squared plus 4 quantity to the 1/3. So it's thinking the outermost function. Outermost function is the cube root function, the raising to the 1/3 function. So the derivative of something raised to the 1/3 power is 1/3 times that something to the, what's 1/3 minus 1? Negative 2/3 times the derivative of, and here's where I'm going to play fast and loose with the notation. I'm not going to write, I probably should write d dx of x squared plus 4, yes? Yes, I should. When you go back and look at this, you'll think, where did the 2x come from? Oh my goodness, he's just making stuff up. And I might be, but at least I need to leave good directions as to where it came from. d dx of what's inside the parentheses. So multiply by the derivative of what's inside the parentheses because the chain rule said so. X squared plus 4 to the 2/3. Multiply those exponents and that's what we get. 1/3 times 2 equals 2/3. So we'll take the derivative of x squared plus 4 and get 2x. Maybe there's some other things that we can do. Is it too soon to think about factoring a common factor out of the numerator? X squared plus 4 to some power? F prime of x equals, it's not too soon to start thinking about it. It feels like it's too soon to start doing it. X squared plus 4 to the 1/3 minus 1/3 x times x squared plus 4 to the negative 2/3 times 2x over x squared plus 4 to the 2/3. So not a whole lot of excitement there. Derivative of x squared plus 4 is certainly 2x, and the x and the 1/3 just kind of swap places because I like the coefficient out in front to the expression if possible. A little bit more that has to happen there. Goodness. Copy and paste all of that, and what's going to happen? The 2 is going to find itself in the numerator of that fraction, call that 2/3, and instead of an x there and an x way over there, I'll just have an x squared. That's all that's really going to happen there. So here goes. Don't want to erase that. F prime of x equals x squared plus 4 to the 1/3 minus 2/3 x squared times x squared plus 4 to the negative 2/3 all over x squared plus 4 to the 2/3. Okay, now it's time to factor x squared plus 4 to some power out of the numerator, and once we do that, we'll be able to get that together with the x squared plus 4 to the 2/3 down in the denominator. But let's first deal with the numerator. We've got a power of 1/3. We've got a power of negative 2/3. What is the lesser of those two powers? Negative 2/3. So I'm looking at it, I'm thinking I don't want a 2/3 inside the parentheses. I don't want to leave a fraction inside the parentheses like this. So I'm wondering if I shouldn't, at a minimum, factor out a 1/3. It's a little weird, but I want to think factor out a 1/3 times x squared plus 4 to the negative 2/3. And then we'll have an x squared plus 4 to the positive 2/3 down there. If I don't factor out that 1/3, then I'll factor out what I have, and then inside the parentheses there'll be a polynomial with the fractional coefficient. And I don't want any polynomials with fractional coefficients inside. I just want integer coefficients, if I can keep it that way. So that's why I'm just trying to look ahead and deal with that 1/3 proactively. So we look at it and we ask ourselves, well, let's just ask ourselves this. 1/3 times what equals 1? Can we answer that question? 1/3 of what equals 1? 3. We're going to need a coefficient of 3 for this first expression here. I need a 3 there because I factored out the 1/3 when the first coefficient wasn't really divisible by 3. So I factored out the 1/3, and then x squared plus 4 negative 2/3 plus what equals positive 1/3? 1. So again, we don't have to write the 1. We just have to know that there's a 1 there, an invisible 1, if you like. Minus 1/3 times 2 will give us the 2/3. And I guess that's enough, huh? Kind of anticlimactic for the numerator there, but that's really... Oh, no, we need the x squared, don't we? Yeah, I almost overlooked the x squared. Sorry about that. Didn't mean to scare anybody. It scared me. Hopefully no one else. X squared. All right, is that good? Maybe not the final answer, but so far so good? Sure. Yes. All right. So let's do two things. Let's get the x squared plus 4 to the negative 2/3 and the x squared plus 4 to the positive 2/3 together somehow. We like positive exponents. So if we take that x squared plus 4 to the negative 2/3 and shove it down to the denominator, it'll look like this. Why don't we take the 1/3? That's like 3 to the negative 1. Shove it down to the denominator, we get 3 to the positive 1. All right, x squared plus 4 to the positive 2/3. Another x squared plus 4 to the positive 2/3. And then let's deal with what's inside the brackets there in the numerator. If we deal with that, Distribute the 3 across the parentheses, since that's just a 1 there. I'm going to leave it visible. 3x squared plus 12 minus 2x squared. Are we in a position to write the final answer? Is it about time? F prime of x equals x squared plus 12. Over 3 times x squared plus 4. Add those exponents. 2/3 plus 2/3 equals 4/3. And the final answer looks like this. Comparatively nice, I think, compared to how it looked in the middle. In the middle, it was really rough. A moderately elegant looking final answer.